This is WFNP 88.7 Rosendale. Welcome to Curiosities of the Cosmos. I'm your host, Allyson Sheneman. Today it's just me, talking astrobiology and graduation. Welcome to Curiosities of the Cosmos with Allyson Sheneman. Today, I am not joined by a guest. Instead, I will be properly introducing myself and talking about my own research, astrobiology as a field, and plenty more. So I feel as though in these first few episodes of this season, I really wanted to do a lot with introducing other people, trying to kind of capture the world of their research, the world of my experience as an undergrad at New Paltz. I wanted it to be kind of like a time capsule in a way of all of the people that I've met, all of the kinds of conversations we were having. And I just feel very honored to have had so many incredible guests on the show, to have been able to talk with so many people who are really just at the precipice of beginning a career and seeing where they're at. So I'm really excited now to just kind of be like, hey guys, this is me, the person that's been asking all of the questions this whole time. So first little thing to just cover before we do anything else is that I've still got my camera the same way that I would if I had a guest sitting in the chair next to me, but I also have camera number 2. So I guess I'll just try to switch back and forth between them throughout the course of the show. And try to remember that they're both there. I think I'll probably primarily use this one though. So this is just kind of like a throwback to the time that I was talking to a guest the whole season. So typically during the show, I would first start by introducing a guest. But yeah, I realized having done so many episodes now and kind of closing out the season, as this is the last episode of the first season of the show, that I never really actually properly introduced myself. And so I guess that's kind of the purpose of this episode. It's already incredibly weird to not be handing it off to somebody else to talk. So I'm really actually kind of excited to just get a chance to yap for an hour. So I hope that there's some interesting stuff in here. I hope it gives you guys a sense of maybe the qualifications that I currently do and don't have, and what kind of motivates me to do what I'm doing. But yeah, I'll also, to end the show, I'll probably give a little bit of a preview as to what I'm expecting the future of this show to look like, and what I expect season 2, which I am very excited to announce will be happening, will look like. So yeah, so my name is Allyson Sheneman. I am currently a senior, but that is only going to be true for a couple of more days, which is absolutely unreal. I am a part of the honors program at SUNY New Paltz, and I double majored in astronomy and biology. So I've worked at a lot of different departments in a lot of different roles, both on and off campus. And so I guess maybe at some point I'll go over more of a bit of the resume that I have. But for now, I'm just going to kind of mention some of the roles that I worked in within science and what are kind of more pertinent, I feel, to talk about on a show like this. I've worked at a planetarium for the past 3 years, and I've presented dozens of shows. I've really, truly, deeply loved working at the planetarium. I also have and continue to work as through the astronomy and physics department as a tutor for introductory astronomy courses, which has given me a lot of experience working with students who come in from a kind of gen ed perspective, who are just interested in taking the course to fulfill some box on their transcript. And so I've had a lot of experience trying to motivate people to be interested and who are maybe interested but feel intimidated by it. I've really loved being a tutor. It's been so much fun. I'm also on the executive board of our biology club. I've loved being a part of the biology club. I was just yesterday in New York City with the biology club for a trip to the Central Park Zoo, which was so much fun to go to. I highly recommend for anybody who's visiting the city. But I've loved being a part of the biology club and kind of meshing my two interests of astronomy and biology in my time here. And in addition to these and several other things that I've been a part of in my time here, I've also conducted a few research projects that I'll kind of break down and discuss more in depth throughout the course of the show. So that's, I think, probably a pretty good overview as to who I am and what I've done. I have really just tried my best in undergrad to be a part of pretty much everything that I can be as much as I can be. So I'm a very busy person. I do a lot of different things, and I've loved thoroughly doing all of them. There's nothing, genuinely nothing about my undergraduate experience that I would change. I have truly, truly, deeply loved being a part of everything that I've been able to be a part of. I'm so grateful for all of the opportunities that I've had while in my undergraduate experience here, in working jobs, in developing interests and hobbies, and in furthering my education. The courses that I've taken have been so incredible and so fun and extremely rewarding. The research process is something that I've fallen deeply in love with that I did not fully anticipate in arriving here. And I'm just, I'm very, very grateful for my entire undergraduate experience. So I guess first I'll really try to dive deeper into what the purpose of this show is and why I wanted to make the show. So I'll start by admitting that I was very, very, very anxious to start this process. This show had been in the works for a little under a year before I actually started filming the episodes. It's been in the works for about a year now total. In concluding this, it will be a year. And so I was just anxious about the whole process because I knew, I guess less because I knew that it was going to be work. I knew that it was going to be work, but I'm no stranger to doing that work and to doing that work for the things that I love. Whether that's through the jobs that I've talked about or just developing interests, going to events, things like that. I am no stranger to working hard for the things that I want to do, but I do feel I have a sense of fear around doing things imperfectly. And that doesn't work well with a world and a life that is full of imperfections. It's impossible to avoid imperfections, and so being afraid of them means that you're constantly nervous about messing up, about things not going perfect. And I think something that I wanted to do with this show was to let it be its imperfect self. I didn't want to be so controlling about the process. I didn't want to decide that this is the only way that this could happen. I didn't want it to be scripted. That's something my last episode with Jacob, he was so funny at the end of it. He said, we discussed this briefly before the episode started, but I want you to know that's the only thing that we discussed beforehand. It's not scripted. And I was like, it was kind of validating in a way, I guess, to hear him emphasize that, because I really do pride myself in the fact that this show hasn't been scripted, that there's no part of this that isn't just kind of me and my guest as our authentic selves. And the only part that's scripted really is I have an outline that I tend to follow a little bit. But even that, I try my best not to read off of. And so I really just wanted it to exist in all of its imperfections, just the way that it is, you know? And eventually I came to the realization that the same reason that I wanted to, or that I did hesitate in starting doing this show, despite the fact that I had been prepping it for so long before I actually started it, was because, and it's for the same reason really that I hesitated to study science and to go into astronomy and bio. And I think it's just because I didn't know if I was good enough. And it took me a long time to get to this point. But I have learned in my undergraduate experience here, I have learned that if being good enough means being perfect, then I will always fall short. That I will always stop myself from doing what I love to do. And so I decided that it was time to just fully go for it, you know? And I'd been unintentionally almost easing myself into doing things like this, just because by doing the things that I love doing, I was slowly working myself towards doing another thing that I love doing, which I guess is the benefit of really dedicating yourself to something that you actually love. And so in working shows at the planetarium, I was developing a sense of science communication, a sense of reaching a public audience and what the public does and doesn't know about science. But I was also developing a way of speaking artistically and poetically about science. And I think that is something that is certainly underrated about science and about going into this as a career, and just not seen as important as I feel it is. And I think that working in the planetarium has given me a sense of how to speak about science in a way that conveys its like majesty and beauty and the awe that I feel about it. And I've also had a little bit of experience with the social media side of things. I had a sense of how to market the show, how to do some of the design stuff. Certainly it is a scientist who has a hobby of doing design stuff and not a professional designer who's doing the show. But I have really thoroughly enjoyed that process, the creative freedom and control over such a project, and being able to do social media I did social media for so many places. Oh my gosh, I've done it for the honors program for 3 years. I did social media for admissions. I've done it through residence life as an RA. I did social media, and I currently do for the biology club. I've done that for a few years. I've done social media pretty much everywhere. I started and run the planetarium social media. There wasn't anything for the planetarium at my school on social media before I started it, and I was like, this has got to change, and I'm going to be the person to do that. And so I just kind of volunteered to start with that. And so I've really leaned into doing social media as a way of communicating science. And I guess that really has lended itself well to the transition that is doing this show. And I also have some experience with the marketing and the putting myself out there from doing music. That was something that I was very passionate about in high school. I never fully pursued a career in it or anything, but my high school experience was loaded with music. I did concert band and jazz band. I did guitar for the pit for one of our musicals. I worked at an after school center where I taught guitar and bass. I had loads of music experiences, and I did music theory in my junior and senior years of the diploma program. I did my extended essay, which is kind of like the capstone thesis type of essay for high school when you're in IB. On jazz music theory, I was really, really in love with music, and I've always known that it was never going to be my career. I don't feel I've ever wanted it to be a career. It's not like I gave up on a dream there. I just kind of knew that it wasn't the thing that I wanted to do. It's just something I want to do for forever when I can. But so my senior year, I'm a high school graduate of 2020, so I graduated in the pandemic. I didn't get to walk across the stage. I didn't have a graduation party, anything like that. And so when we shut down and everything went online, I leaned into two things. I leaned into my job working at the after school center, because we moved that to remote, but we still offered lessons. We still did everything. I worked the summer camp that year doing lessons. And I leaned into that, and I leaned into making an album. I had slowly been making musical pieces and composing throughout high school, really. But as a part of the IB music theory track, I really pursued making music and making it myself and being a part of all of the stages of music making. And in doing so, I really decided that I thought that making an album was the perfect send-off to my senior year. I guess in the same way that I decided making this was the perfect send-off to my senior year of college. And so well, as much as I want to continue to pursue both of those things, they were really things that I did as like goodbyes to places and people and things, and a chapter of my life. And so I released an album. It's called Le Monde. It's an album completely in French. I did all of the music, all of the composition work, all of the lyrics. I wrote it all myself. I did little music video things for it, lyric videos more so. And yeah, thinking back on it, I mean, I'm sure that now I could do better, but I'm so extremely and incredibly proud of myself for having done it to begin with, because it's like an intimidating thing to do, and also a thing that is, again, full of imperfections. And so I think it's, I love that I did it. I'm glad that I did. I want to do things like it in the future, but I think it definitely prepared me for what this was going to be like. And so, yeah, I just had this like perfect storm almost of experiences and skills that led me to being able to do something like this. And I felt like this show in particular felt like the perfect way to combine this like deep love that I've developed of science, and both science and science communication, really, and being able to put myself out there completely and fully and honestly. And so I've just been really leaning into what it means to be a science communicator, what it means to be a scientist, what it means to be somebody on the internet, really, like who like puts out any kind of content, and certainly it's to a really small scale, and I almost in a way prefer it that way, but just to really embody what all of those things mean, and to lean into and embrace the fear associated with that. So in saying that, also thank you to everybody who listens. I've mentioned before how grateful I've been to have the guests that I have on the show, but genuinely it's incredibly flattering to have people who listen and support the episodes, who comment and share them and all of that stuff that I just, I'm incredibly flattered. In doing this first season, I obviously don't have the numbers for the last couple episodes, including this one. But we've reached, these episodes have reached tens of thousands of people. It's well over 10,000 as of the time that I'm recording this, and I am just like humbled. I'm flattered. It makes me feel like I am filling some kind of gap here, and it's just been such a blast to do it that I'm so honored that it's been something that's been well received, even on a kind of smaller scale. But yeah, I just like to thank everybody for a moment. The people who listen, who comment, who support the episodes, the people who have carved out their precious and busy time to come on the show as guests, to people who have like really pushed me to like seize this moment and opportunity, to take advantage of the resources that I've had to be able to do a show like this. I am so deeply indebted to them. It's to all of you. It's genuinely been like such a rewarding and all-encompassing experience. So I'm flattered, I'm honored, I am happy to be here to be able to do an episode of just me on the show. And I foresee in the future, as I continue to do the show for season 2, I will be a graduate. I will have left undergrad and I will be moving into graduate school. And so I imagine the transition period there might be a little rough for what the show will look like. I'm going to have some episodes that I record a completely kind of new approach to the episodes. I've taken a little bit of time to sit down and evaluate what I've liked, what I haven't liked. I kind of just came up with a format and ran with it. And now I've had a chance to really sit with it and go, did I like this? Did I not like this? What do I want to do different? And so I am going to start with a kind of new format to the show. It's going to be similar, but it's going to be a little different. And I'm excited to start filming those soon even. And have some kind of locked and loaded for a season 2 release, but the exact timeline and details of all of that is kind of difficult for me to understand at the moment with what graduate school looks like. So yeah, just keeping that perspective in mind of what the show is going to kind of progress into. And so I want to also say that I am no exception to the segments that have been on the show, and to what the show is all about. And so following that format, I'm going to do some of the segments still for myself. I don't feel that the fun fact one, the Curiosity Corner, really has a place in this episode because I can't like freshly react to anything. And so I'm still going to do Should We Be More Worried About and the Favorite Questions one. So the segment Should We Be More Worried About is a segment that I created in order to address public concerns. And so I've had people come up to me with a slew of different things. In being in public science communication, you really get to hear everything. It goes from conspiracy theories, like verging on conspiracy theory, to like just fundamental misunderstandings of science, to things that they just don't know anything about, but they might be concerned about, and also things that they don't even know that they should be concerned about because they don't know about it at all. And so I feel this segment was really important to me to address some of those concerns, to determine if they were worth being concerned about or not, and to have those questions posed on a public scale. And so gathered from these experiences in public science communication, I have compiled this kind of list of questions that people have asked me that I wonder if the public would maybe benefit from knowing if that is something worth concern or not. And so, so my question for me today that I think people are probably going to be pretty interested in, I hope, and I think relates back to my experience in astrobiology, because I don't want this episode to just be like me talking about the show. There's plenty of time for that in all seasons, and I'm sure I'll talk about a lot of it. But I want to really lean into the astrobiology that I've done in my time here. And so my question to myself, for all of you, is should we be more worried about aliens? So whenever I tell somebody that I am interested in or have pursued a career in and have degrees in astrobiology, they ask me about aliens. It's like the first thing every time. So my answer to should we be more worried about aliens is yes, but probably not for the reasons that you think. So I don't think that we should worry about whether aliens are already here, if they're controlling the government. Like I don't think we should worry about aliens in that way. And I don't think we should be actively worried about aliens in the like, what if they're hostile and they take us over and this and that kind of way. I don't think there's any real cause there for or reason for active concern. But I do think there should be some cause for concern as to why we haven't already heard from them. So that gets us into a thing called the Fermi paradox. The Fermi paradox is simply put the question, where is everybody? Like, if life should be easy to form, which it should be, because there are abundant materials in the universe, and there's energy from the sun, there's liquid, typically in the form of liquid water. These things are not that uncommon. And so life should be widely spread. It should be abundant. So life should be easy to form, right? In addition to the fact that we have all the building blocks, the energy, the liquid water typically is there. Life also happened really quickly after the Earth formed. It did not take very long at all for life to begin to develop once the Earth had formed. And so theoretically, right, if life can happen quickly after formation of planets, and planets in the scale of the universe formed not that much later than stars and stuff like that, and given that the Earth is only a few billion years old compared to the almost 14 billion years that the universe has been around, aliens should have like billions of years of a head start on us. And so the question then is, where are they, right? There's a handful of ways that we can approach answering this question. So you can either answer it in terms of, I separate it out into three categories in terms of technology, sociology, and time. So in terms of technology, you could say, where are aliens? Well, technology could make them undetectable, or technology could be the limitation to colonizing things at such large scales or communication at such large scales. And so this concept is called the Great Filter. It's kind of asking, what is the stage at which the cutoff would be for all of the things to work out in order for us to have heard from aliens. And so it may very well just be that these huge, vast distances and scales are just too vast and distant to be able to communicate across. So there might be a technology factor that limits us there. There may also be the sociology factor, which maybe has this twinge almost of, we're advancing so much, and these aliens might advance so much to the point where they just lose interest in colonizing a galaxy or communicating to other potential life forms. But it may also just be that civilizations self-destruct before they get to that scale. And that really is the sociological perspective, is that in terms of answering the Fermi paradox, is that maybe civilization is not able to get to that point, and they are doomed to self-destruct first, or that they, like maybe how life began on Earth, which was more like with in terms of being able to get to really advanced life, something like the dinosaurs, where then it gets wiped out and it has to start all over, and it's not even their fault. So it's like that, or it could be like nuclear warfare for us, and the idea of kind of self-destructing our like civilization and species. And then there's the other option. It could be temporal. It could be time related. And that, again, just perhaps the lifespan of civilizations is short naturally, and therefore our civilization is just existing at a time where it doesn't coincide with other civilizations existing. So again, it's a complicated concept. I don't think there is a right answer, which can make it kind of intimidating, but it's really what I love about the field and about the topic, that there isn't an answer. It's just kind of like cool guesses and scientifically backed guesses, being able to kind of evaluate what it is that we think might happen and why, being able to rule out the options that it isn't. But I think, what that means for Earth and for humanity is yet to be determined, and largely is determined by us, and what we kind of do with the like privilege that is life that we have. But I think, I think when people think about being concerned about aliens, they're concerned about like alien ships descending upon them, and really I think you should be concerned about why that hasn't happened, and why we haven't received any communications from other civilizations. And I think to put that in context, when we consider the communications that our civilization has sent out, a civilization that we like to perceive as being very technologically advanced, the communications that we've sent out have barely reached outside of our little sphere of influence of our solar system. I mean, we have technically reached interstellar space, and we are out of the influence of the sun and our solar system, but only barely, and not for very long. And so I think if this is something that we're really committed to as a species, we would have to have dedicated more to it. We would have to continue to dedicate more to it, and to knowing how to look for these signals and where to find them. It's a very complicated subject, and there isn't a clear answer. And so I think it's a really great starting point for people who are interested in science, as long as you don't go down too many conspiracy theories about it. To get to the real science of it, I think is really rewarding, and a really like fundamental and like deeply fundamental scientific experience. So it's interesting food for thought. I'm interested to hear your thoughts on the matter. So feel free to leave some comments. Let me know what you're thinking. And so with that being said, we are going to cut to our first short break. So stay tuned and we will be right back. Welcome back to WFNP 88.7 The Edge, Rosendale. You're listening to Curiosities of the Cosmos with Allyson Sheneman. And we're going to continue talking more about astrobiology. Again, I'm your host, Allyson Sheneman, a senior and student of astronomy and biology at SUNY New Paltz. So I've just discussed a little bit about my background in creating the show and just being remembering to be grateful for all of the opportunities and experiences and resources that I've had access to and all of the people that have contributed to my journey. I talked a little bit about aliens and if we should be concerned about them. And I'm going to talk more about astrobiology now specifically. So you might be asking yourself, what is astrobiology? So I like to think of it like it's space biology. And so while that's certainly oversimplifying things, I think it kind of helps to remember the categories almost that topics within astrobiology can fall under, the umbrella that is astrobiology. And so astrobiology, first of all, is a very new field and it's not so well defined. I think when you ask like somebody what is physics, there's a very concrete answer to what that is. And astrobiology is a little too new for that. And so astrobiology really right now is whatever we make it to be. And so for some people, it's astronomy with a little bit of bio. For some people, it's bio with a little bit of astronomy. For some people, it's bio that exists almost completely outside of the context of astronomy that might have impact on astronomical questions. And so it really depends completely on the intention of the research, the purpose of the research, what the research is used for, whether certain fields and topics are covered under this umbrella. And so I kind of break it down into a handful of categories. It's either finding habitable planets and finding what it means to be habitable outside of our solar system, finding life that already exists outside of Earth in our solar system and habitability within the solar system, or putting our life elsewhere, and as in astronauts, human bio, or NASA grew plants in like moon soil, that kind of thing, like being able to talk about what it would be like to move our life elsewhere into the solar system. And so, yeah, it kind of encompasses where like how life came to be, what the requirements of life is, where life exists. And so, yeah, it's this crazy cool, like, it's evolution, it's atmospheric work, it's astrophysics and how we define habitability and habitable zones. It's looking at spectra, which is just the components of light, and being able to look for molecules in that. It's fascinating. So I'm going to now talk about a little bit more on my specific research that I've done. And so I'm going to try my best to keep this in this kind of like narrative form. I had a guest on the show this season, Phoebe Harrods, who did an incredible job. I loved the like narrative that she told about the courses or the research projects that she's taken in the course of her experience being a scientist. And so I'm going to try my best to try to do some kind of like narrative form of my research, and how I've gotten into the projects, what they've taught me, what I did, and that kind of thing. So I'll start out by talking about the very first research project that I was ever a part of. And so starting out my first year in undergrad, everything was online, and I had no concept really of what being a scientist in the day-to-day sense looked like. I didn't know what it would mean to do science in terms of what my daily life was going to be. And so I just knew I loved science. I knew I wanted to learn it, but I didn't know what being a scientist really was yet. And I didn't realize that it was pretty extensively doing research. And so my first year, everything was online. There were very few opportunities. I think that's true for everybody. And so I kind of like sputtered a little that first year, trying to figure out where I was going, what I was doing, and how I was going to do it. And then my second year, I applied for some summer research programs, really only like 2 or 3, because again, I had no concept of the scale and extensiveness of this as both an essential part of doing research and also as a thing that's very highly competitive. And so I didn't realize really what that process would look like. And things were only just kind of starting to open back up on campus and starting to be regular again. And so my sophomore year, I started looking into research opportunities. I applied to very few, and I wasn't really sure what I was going to do. And I was fortunate enough to be added to a research team in biophysics. And so at the time, I wasn't doing any physics really. I was an astronomy student, and I'd done some general physics. But I certainly wasn't thinking that physics was the thing I was going to pursue. I didn't realize that astronomy and physics were so overlapped, especially at an undergraduate level. And so I was nervous about doing a biophysics project because I wasn't sure that the physics side of things was really for me. But I have truly, deeply recognized now that it is absolutely something that I'm interested in, that I'm passionate about, that I've loved doing. I'm so glad that I had the opportunity to do it and that I was able to take advantage of that opportunity. It was like right time, right place. The main professor who does research on my campus sent out an email asking if anybody wanted to do research, if they were interested in kind of interviewing almost to be on the team. And I immediately was like, yes, that is the thing that I am supposed to be doing right now. And so I sent the email. I did a little interview walkthrough of the facilities, the resource lab or the research lab, and the space. And she brought me on her team, Dr. Catherine Hearn, to do research in optical tweezers. So optical tweezers are lasers that are brought to a focus, and that focus kind of looks like, because light, the laser doesn't just exist as like a single point. It's like when you look close enough, it's like a whole shape, really. And so it's like 3-dimensional property in that way. And so it has this when you bring it to a focus using the right mirrors and things like that, you can bring a laser to a focus where it has this kind of like waist-like shape. And at the smallest point of that, at the beam waist, at the focal point, you have enough forces acting inwards to hold small objects there, which is so cool. And so instead of like metal pieces holding them together in the way that like traditional tweezers hold things, it's like the forces that bring that light together, kind of pushing it to keep it there. It's really fascinating. And so the research that I was doing was trapping little bacteria called Dellavibrio bacteriovorus. They're just these really small, little like kidney bean shaped bacteria. And we were trying to measure their attachment rates to Escherichia coli or E. coli. And so we would put the bacteria using the laser over top of an E. coli, press them together using little motors that operated the slide that our bacteria sample was gathered and stuck to. It was like a really cool process that I got to be a part of all of these things. I was the one cleaning the slides, building the slides, propagating the bacteria, using the bacteria, gluing the one to the other, and then using the optical tweezers to measure attachments and recording them. It was really a fun, well-rounded experience to start out my research with. And we were measuring this to study the attachment rates of type 4 pili, so it's a type of little like hair-like appendage that comes out of bacteria, and to measure how long it takes for that appendage to form an attachment with the prey bacteria, in this case E. coli. And so the purpose of this was to be able to potentially use this for biomedical purposes, and to be able to use these bacteria to combat increasing antibiotic resistance. So we found really fascinating results that this attachment rate is much, much, much faster than we thought before. And so the last research done on this was in the 60s, 70s, and they thought it was in the field of 10 minutes. And we had determined that it was closer to like anywhere between 15 to 30 seconds, which is really promising. And so we brought this to the Frontiers in Optics and Laser Science conference in Tacoma, Washington, my research partner and we did a presentation. It was an incredible trip and experience. I learned so much and discovered a real love for physics and for optics. And I also presented this at the Student Research Symposium in New Paltz on campus, and I did a poster there. And so this experience was so well-rounded and all-encompassing. I did it my entire junior year and then continued that fall to do some stuff with the presentation side of things and going to the conference that happened October of my senior year. And it was just this incredible experience to be able to work with all aspects of the research like that. And so it really got me invested in doing research. So I started that the fall of my junior year, and that upcoming spring, I took on as many projects as I could. And so one of the projects that I took on was studying extremophiles. So this is a new project. That spring, I picked it up. It was a 1-credit project at the time, and now this spring, currently of my senior year, I'm finishing it out with four more credits of the research. I was really invested in it. I'm very happy to have been able to continue it. And this is working with Dr. Maureen Moreau. She is one of my biology professors. I took microbiology with her, and capstone microbiology, and I was able to determine the amount of soil needed and to develop a procedure for investigating the soil from both within regions affected by a wildfire burn and outside of those regions. And so I compared what the bacterial diversity looked like within samples within a wildfire region and without the wildfire having passed through but nearby. And I was a part of the DNA extraction. I really did all of the DNA extraction. And this was also my first research project really where it was just me. And I wasn't a part of a research team. It was just me doing a project. And so, yeah, we're working currently to do more of the genomic sequencing side of things and looking for specific sequences and what sequences are present after a prescribed or after an unprescribed wildfire forest burn, and that can maybe give us some insights into the types of genetic sequences and the types of bacteria that can survive, and what makes them extremophilic, which extremophilic just means that they're able to survive in extreme environments. So in this case, it would be a very hot environment, and often after wildfires go through a little in the terms of the ecology side of things, the soil can be more nutrient poor. There tends to be more duff, which is more like dry material, like when you think about a forest that has a lot of like pine needle litter on the ground, that kind of thing. Litter as in the pine needles are the litter, not like trash. And so yeah, I was really interested in getting being a part of this project for the extremophile side of things and how that connects to astrobiology and the types of life we might find outside of the solar system, in the solar system, outside of the Earth, and also what that might mean for like sanitation purposes, for like making sure that when we send out rocket ships that we're not covering them in bacteria before they land places, bacteria that can survive in harsh conditions. And so yeah, I presented this research. I did a poster at the Hudson Valley Life Sciences Symposium and at the Student Research Symposium again at New Paltz, 2 different posters for presentations there. Genuinely an incredible experience. I've loved doing biology research. I have also that same spring picked up another research project. So this was the spring where I was still doing my optics project with the biophysics. I was doing the wildfire biology project, and I was also picking up a credit in research for observational astronomy. And so I had just taken the course where you learn how to operate all of the telescopes on campus, and I was really interested in using them for things that people hadn't yet tried using them for. And so I worked under the advising of Dr. Amy Bartholomew, the chair of our physics and astronomy department, to less so do the research and more so do the observational process that goes into research. And so I used our observatory and our telescopes to look at the atmospheres of both Mars and Venus for ground-based observations, which means you have to first look through the Earth's atmosphere in order to get to these other planets' atmospheres. And so even though the signals are really strong from these planets because they're in our solar system, they're near us compared to exoplanets, which are planets outside of the solar system, it's really hard to get rid of the Earth's atmosphere from those that observational data. And so my research was more so just trying to learn how to use the telescopes and how it's used for this type of observational work, and using diffraction gratings, which just have like all of these little like slits in them, really, to spread out the spectrum. They work as like a prism, and they spread out the light that we get from a planet into all of its component parts, and then we get to analyze where there's little dips and stuff from where the atmospheres absorb bits of the molecules. And so I was able to work with the diffraction grating, work with our telescope on campus, and put together some observations of these planets and then examine what their spectra looked like. And it really, really taught me that the Earth's like atmospheric contamination is so strong and thorough that it's hard to observe the spectra of anything else from the ground. And this project prepared me so specifically and perfectly for the project that I did this past summer. So ending out my junior year, I was accepted to the Research Experience for Undergraduates program, the REU program, which is a summer research program that I did at Cornell University through their Astrophysics and Planetary Science department. And I was researching the contamination of the Earth's atmosphere when we're looking for signals from exoplanetary atmospheres of planets outside of our solar system, very far away in other solar systems. And I worked under Dr. Adam Langeveld. He was my direct mentor, and then he was on the team where our PI was Ray Jayawardeneh, and the REU was run by Dr. Alex Hayes and Dr. Brittany Schmidt. And I met so many incredible people. I genuinely could not be more grateful for the experience that I had while I was at Cornell. It was so insightful, and just this like incredible opportunity to have been a part of such high level research, and with so many people who are like in the prime of their like very extensive careers. And so I feel very, very fortunate to have been able to be a part of that. I met some incredible people through that program, both the other undergraduates who are a part of it with me, the undergraduates who attended Cornell and were staying for their own summer research program called Nexus. I met a lot of the professors and graduate students there. It was really a phenomenal experience. And a little shout out there to Patricia, who was the coordinator for the REU. She was incredible. She taught me so much, and was really a great person to have bringing me into that experience. She helped really smooth that transition over. And so the research that I did there, I've continued since at SUNY New Paltz, under the advisement of Dr. Amy Bartholomew again, continuing that observational trend, and Dr. Patricia Sullivan from the honors program, the director of the honors program. And so I've been able to do that both as a part of the REU and also for two different senior kind of capstone projects during my senior year here. And so it was the REU, it's my honors thesis, and it's also my physics senior project. And so I started learning code for it. I had never coded before. I had never done any programming. and I learned that coding is so deeply combined with what science is really now. And so it's hard to do science without code and without programming. And so I did a lot of coding. And what we looked at was, again, how the Earth's atmosphere contributed contamination to the spectra that we were looking at from exoplanets. And we were trying to examine if there was any regions of spectral data that we could isolate, that we could still use, that we currently were just kind of blocking off as contaminated regions. And so I was analyzing statistically using different statistic methods, the accuracy of our corrections, and if there was any regions or any type of way that we could maybe get more data out of the observations than what we were considering at the time. And so I did a lot of work with that. I continued it again as my honors thesis and my physics senior project. I have also presented that research a lot of times. I was able to go to the American Astronomical Society conference in New Orleans, Louisiana this past winter in January 2024. And that's the largest astronomy conference in the world. It was a blast to be a part of. I presented a poster there, and I won the Chambliss Astronomy Achievement Award. So that award is based on the poster and the presentation of the poster, and it's only given to a handful of the hundreds of people that present their posters there. And that was like such a crazy, surreal experience. I'm so fortunate to have been able to do that, and I feel so grateful to have been selected for that award. It's really genuinely, truly an honor to have been a part of that. I have presented it for my honors program thesis presentation, and through the physics and astronomy department, I presented it both as a part of the summer research talk series and also for my physics senior project. So it's been a truly, fully, completely encompassing project, and I've done so much work on it. It's a lot of hours of sitting with code and staring at it and trying to figure out what's going wrong and what's going right, and it's been such a rewarding experience. So yeah, that really takes you through to the end of my senior year here. With all of the different projects that I've been a part of. I will add a kind of honorable mention almost in a way. Through my biology department, I've been a part of the development of a protocol for submission of data for a phenology project. So phenology is measuring the timing of when specific phenomena occur in plants. For example, a thing called leaf out, which is where in the spring all of the leaves of plants suddenly start to appear. When flowers start to bud, when flowers begin to show, that kind of thing. So there's all these different events that happen as plants progress throughout any given year. And so we time when those happen throughout the year to try to get a better understanding of how climate might play a role in some of those things and what the strategies of plants are. My senior year in particular, I really fell for my plant classes. I've taken plant morphology and plant ecophysiology, and they are incredible classes. I've loved being a part of the plant community on campus, and taking the nature walks to look at the trees, that kind of thing. I've really, really loved being a part of going to the greenhouse, things like that on our campus. It's been a truly incredible experience, and I was fortunate enough to kind of, I guess as a last minute senior thing, be kind of a part of the phenology research project. I didn't do it for credit or anything, and I don't need volunteer hours for a thing. I just kind of was interested in seeing what the data looked like and how the research happens in phenology. And so Dr. Eric Keeling was kind enough to let me kind of poke my head in a little on some of that. And I was able to develop a kind of protocol, a procedure for submitting data for the National Phenology Network. It was kind of a small role in a much bigger picture project, but it was a lot of fun to still be a part of. And that is this kind of capstone to my time here. So those are all of the research projects that I've been a part of. and I'm really excited to go into graduate school and continue doing research. But it's been so much fun to have been a part of all of those different projects. I have loved being able to develop passion for each of them. I think advice that I would give to somebody who is maybe interested in pursuing science but not sure what that looks like for them, to make sure that you are the kind of person that loves learning so much that you could be interested in learning just about anything. And so I love, for me, for example, I love that I can be handed an optics project and still find this incredible love and passion for it. And I can also do coding, and which is something I thought I wasn't even going to like, that I really love doing. There was a lot of math involved in that too, with the statistics side of things that I really love doing. Working with extremophiles and with bacteria, with DNA extractions and PCR testing to try to isolate regions of genetic sequences and stuff. It really, science is just so encompassing. It's hard to do science and not do so much of it. And so definitely, if you're interested in pursuing science, being interdisciplinary is so helpful. It opens up so many more doors to so many more opportunities. And so I highly recommend taking some of that more interdisciplinary approach. With that being said, I will cut to my next break. So that's, again, that summary of my research. You're listening to Curiosities of the Cosmos with Allyson Sheneman. We'll take a short break and we will be right back. All right, welcome back to WFMP 88.7 The Edge, Rosendale. This is continuing with Curiosities of the Cosmos. I am your host, Allyson Sheneman, a senior and student of astronomy and biology at SUNY New Paltz. For our last few minutes here, and to end every episode, I always ask my guests to bring in their favorite question that they've ever been asked. So today I brought in my favorite question. After one of the planetarium shows that I gave, someone asked me why the moon looks like it's following them in their car. So, first of all, when you're driving, don't look at the moon, look at the road. I know it's tempting to look at the moon, but I think that's such a cool question. I think so many of us have that experience of being like 6 years old and being like, why is the moon following me? And the answer is really simple. It's that, and probably more simple than you'd expect. I think any of you could have all of the resources already to be able to explain this to yourself. But consider the distance really quick between you and your car and like the trees and the road and all of the things that you're seeing in your scenery nearby, and then consider the distance to the moon, which is nearly 240,000 miles away. So when the moon is at its furthest distance in its orbit, all of the planets in the solar system could fit within the distance from the Earth to the moon with space to spare. And because the moon is so far away, its angular position doesn't change nearly as much as a tree or a house or something on the road would compared to your car. And so this is the difference that makes it seem like it doesn't really quite appear to move. And so because it doesn't look like it's moving, it looks like it's moving with you rather than just staying still and moving away. Compared to, obviously, all of the trees and houses and stuff that you might be driving by. And so when I first got that question after one of my planetarium shows, no one had ever explicitly told me that that is the answer to that. Nobody's ever sat me down and been like, this is why this thing happens. I'd asked that question to myself when I was 6, maybe 8 years old, and I was not at the time equipped to be able to answer it. And so the last time I had answered that question, or I had asked that question, I didn't have the resources yet to answer it. And the next time that I was asked it was at the planetarium show. And so it showed me, because I was able to answer the question and able to give that kind of comprehensive response, it showed me that when given the right tools, everyone is capable of answering these kinds of questions. And so there was a part of me that felt sad for the person that asked it, because it feels like to me an example of how the education system has failed that person. That person doesn't have the resources to be able to answer that question, despite the fact that they are no longer 6 years old and should have gone through those classes and have that understanding by now. I feel very grateful that I was able to, in that short time, cultivate a space where they felt comfortable asking it again, and where they were able to get an answer. But it shows that the people, even who are most curious, who go on their spare time to planetarium shows, who have the questions and want to ask it, just need the tools to be able to do so. And so, I don't know, it's a very complex topic to discuss why that person may not have had the resources or opportunities to have been able to answer that for themselves. But I suppose my real answer to that question was to make this podcast, because I want science to be fun for people. I want science to be just as fun for everybody else as it has been for me. And I feel truly and so deeply that the world is a wonderful place full of so many cool things and so many incredible things, that I want everybody to feel like they want to learn about it just as much as I've wanted to learn about it. And so I get that not everybody can dedicate their lives to making that the thing that they do. And I feel very lucky that it's something that I have the opportunity to do. And I feel even more proud of myself that I've been able to put in the energy to do such a thing. But I think at the same time, it just really shows to me that, like, there is an audience for it, there is an interest, and it just has to be made accessible. And so I hope that this podcast has made it more accessible for you, for people. I hope that it makes science fun, and I hope to keep making science fun. And I'm really excited about what the future holds for this podcast. I'm excited for there to possibly be more games involved, for it to be a more fun experience for people. I feel like I've really gotten everything that I could squeeze out of having conversation with people about this kind of thing at the level that I'm at. So I'm excited that I'm graduating, that I'll maybe get to bring on some graduate students to it, or people working in the professional field. And to be able to interview people another step along in their scientific journey. I'm excited that this season, this first season here, represents this kind of complete, like, full circle for me of certainly by no means everybody that has influenced my undergraduate experience, but a lot of key players. I wish that I could have invited on everybody that I've ever met to this show. There are so many guests that I tried to get that schedules just didn't work out, or that I thought would make great guests on the show, but just weren't really sure about what it was going to be like to put themselves out there. And to each of them, I am still so honored that you even considered, and that was a part of a conversation that we were able to share. I'm so grateful still to everybody that did make the time to come on the show. And again, there are so many people that I wish I could have brought on. And I hope to be able to maybe do that a little justice in the future. And so, with that being said, this kind of concludes our first season of the show. Thanks for joining me as a part of it. It's been an honor. It's been a privilege. I had to get all of those things out of the way. I feel like I was saying that a lot during this show, but I wanted to say all of it and really mean it and emphasize it during this episode, because I'm sure that there will be more solo episodes in the future where I can elaborate on other things. But I just want to really emphasize, like, in concluding my undergraduate experience here, I am feeling truly nothing but immense gratitude and pride. I am so proud of myself. I will be the first woman in my family to graduate with a college degree. And there's something so powerful about that to me. And I'm very proud of myself that it's in astronomy and biology. Like, I feel like that, I don't know, it's just so cool. And just, like, again, I'm proud of all of the work that has gone into being able to say all of the things that I've done here. And the work that's gone into the show. I'm very proud, and I'm proud of the little community that I have surrounding this show. I'm proud of the community that I've had to be able to come in and have guests, and the community that I have that listens. And yeah, I'm just really grateful. I'm feeling nothing but good feelings, really, in in closing out this chapter, it's certainly bittersweet. I wish I could just do this forever, but I recognize there's this natural progression of time that I'm experiencing in this way. And so as one chapter closes, another shall open, and I'm excited to see what the next one brings. I feel, again, nothing but pride. I don't feel an ounce of regret for how much time and energy I've dedicated to what I have during my undergraduate experience. I feel I've done just about everything that I could do with as much energy and passion as I could do it in undergrad, given the access that I had to things. And I'm feeling really, really, really good about the past 4 years. And so stay tuned for what season 2 will look like. I'm really excited to work towards making that a reality and what that will look like in a completely new setting. This is the last season with this backdrop and all of this. I might have some pre-recorded episodes, but by and large, this is kind of my goodbye to this setting. It's a goodbye to this era. I will no longer be an undergraduate the next time that you guys see me, besides, again, maybe some pre-recorded episodes, just to get some of those last guests in that I wanted on. But yeah, it's bittersweet graduating. I'm sure anybody who has graduated or is graduating recognizes that feeling. It's hard to do so much and to dedicate so much to a space and time and then have to say goodbye to it. But I again look back with so much pride. I'm so grateful for everything that I've had here. So in the meantime, if you're looking to stay tuned for updates on the show, on Instagram, it's at Curiosities of the Cosmos. On TikTok, it's also at Curiosities of the Cosmos. Most platforms, you'll find it under that. It's Curiosities of the Cosmos with Allyson Sheneman on YouTube, Spotify, Apple Podcasts, Google Podcasts, like everything you could find it on pretty much. So stay tuned on there for sure. Updates in terms of the timeline and stuff should be posted on the Instagram and the website. It's at curiositiesofthecosmos.com, www.curiositiesofthecosmos.com. Updates on me and graduate school and stuff like that, the research that I'm doing. If you want to learn more about any of my research projects, you can find them at www.allysonsheneman.com. With more information on me, on my projects, things like that. If you're looking to kind of stay tuned with where all of that is at until I graduate and everything, and until the next season starts. So with that being said, that is all the time we had for today for the actual podcast itself. So thank you all again for listening and supporting this venture, this experience. And to close out this first season, I wanted to sign out with this monologue that I did for one of my planetarium shows. So I was fortunate enough to have been the student selected to do, alongside one other student, to do the live music planetarium shows. It was the first time that this has been given to students to do instead of our planetarium director. I feel very honored that I was trusted with that experience. And so we had students from an improvisational piano class join us in playing live music to accompany the planetarium show. And so I was able to work with new musicians every time, to create new music every time. And I would like to kind of send us off with the monologue that ended my very, very last planetarium show on campus. So I'm going to play that now, and I hope you enjoy.
We will now embark on a tour from Earth to the farthest portion of the observable universe, setting the context for a deep understanding of galactic scales. This is Earth. As Carl Sagan wrote, quote, "That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives." End quote. As we journey out into the cosmos, try to hold on to the sense of the scale of the Earth within the universe. Continuing outward from the Earth, we find the Moon, our closest celestial neighbor. The Moon is tidally locked to the Earth, gravitationally bound such that one side of the Moon always faces the Earth. The Moon is gravitationally tugging on the Earth, gradually slowing and stabilizing our orbit. Next, we find the solar system, with our Sun at the center. Comprising 99.8% of the mass of the entire solar system, our star, the Sun, fuels life as we know it. We can see our neighbors, whom we briefly visited and mentioned: Mercury, Venus, Mars, the asteroid belt, Jupiter, Saturn, Uranus, and Neptune. As we continue, we begin to find that the Sun itself is simply another star in the sky, a completely normal and average star. This particular collection of stars reside in the Milky Way galaxy, home to approximately 100 billion stars. Here, there are nebulae and supernovae, stars in all life cycle stages. But the Milky Way itself is not alone either. Our galaxy is a part of a local group of galaxies, which itself is within a galaxy supercluster. There are between 200 billion and 2 trillion galaxies in the observable universe, each with plenty of stars that are just like our Sun. This is a map of the observable universe as we know it, painted with a background called the cosmic microwave background radiation. It's a remnant of the Big Bang, the explosive expansion that started the universe approximately 13.8 billion years ago. This clumpy radiation is the oldest light that we can detect in the universe, and is a snapshot of the universe when it was only about 380,000 years old, at the precise moment when the dense universe became transparent. Act 6, Cosmic Homecoming. We've traveled tonight throughout billions of miles and years. We now begin our greatest journey yet, our journey home. Alan Watts wrote, quote, "Through our eyes, the universe is perceiving itself. Through our ears, the universe is listening to its harmonies." End quote. We are the inheritors of billions of years of stardust. We are notes of music played on an ancient cosmic stage. From the subatomic symphony within atoms to the gravitational ballet of great celestial bodies, everything in the universe moves in rhythmic interplay. Inseparably, we are the universe. The stardust in our veins is proof. The rhythm of the tides echoing the moon's pull is a testament. Our very atoms resonate with the echoes of the Big Bang. And the Earth, from the depths of the oceans to the soaring heights of mountain ranges, from coral reefs to rainforests, Earth vibrates with the symphony of existence. We are not just visitors to the universe. We are woven into its very fabric. We, these fragile vessels of stardust, these orchestras of swirling protons and dancing electrons, are not merely witnesses to the universe's grand unfolding. We are, in a breathtaking twist, its beating heart, its whispering mind. Each breath, each thought, each flicker of emotion is an echo. We are the universe remembering itself, its vastness distilled into the intimacy of individual experience. In this profound realization lies not just cosmic insignificance and cosmic significance, but a breathtaking responsibility. It is thus our responsibility to be grateful and appreciative, To thank the plants and trees for performing photosynthesis and giving us our breath. To thank the sun for its warmth and energy that fuels life as we know it. To thank the moon for its gravitational dance that shapes our oceans and guides our nights. To thank the stars for making the elements that comprise our very being. Of all of the gifts the universe has to offer, we are the few and the privileged to have the sentience to thank it. But our gratitude must transcend simply acknowledging the gifts we receive, and must instead embody reciprocating, becoming responsible stewards of this precious existence. It is thus our responsibility to be kinder to one another, to be kinder to the plants, the sun, the moon, and the universe, to be kinder to the earth. Every action we take, every choice we make, echoes throughout the universe, shaping the course of existence. Let us nurture this interconnected web of life, fostering compassion, empathy, and love. It is our responsibility to give this chance at life, at sentience, our very best. I thank each of you and each of the wonderful musicians helping to guide this journey for taking the time out of your evening and afternoon to reacquaint yourselves with your beginnings and the long lineage we share with the universe. As we step out of the sanctuary of the planetarium tonight, take with you this gratitude and connection to yourself, to one another, to plants, to the universe, and to the earth. Because that's home. Our home. Thank you.
And with that, this has been your host, Allyson Sheneman, on Curiosities of the Cosmos, signing off Season 1.